I'm Tim Ventura, and we're joined today by Dr. Reid Blackman, an AI ethics advisor and author of Ethical Machines. He's the founder and CEO of Virtue, an AI ethical risk consultancy, volunteer chief ethics officer for the nonprofit Government Blockchain Association, and an advisor to the Canadian government on their federal AI regulations. He was also a founding member of EY's AI Advisory Board and a senior advisor to the Deloitte AI Institute. Reid's work, which includes advising and speaking to organizations like AWS, US Bank, the FBI, NASA, the World Economic Forum, has been profiled by the Wall Street Journal, the BBC, and Forbes. His written work appears in the Harvard Business Review and the New York Times. Prior to founding Virtue, Reid was a professor of philosophy at Colgate University and UNC-Chapel Hill. Reid joins us today to talk about the many pressing ethical issues surrounding AI and expert systems. So Reid, welcome. Thank you so much for joining us today. It's truly an honor to have you here to explain some of these issues. So let me start out by asking you, what got you into this field of expertise? How do you end up with AI and ethics as a focus area?
So it first came by way of just ethics. I was, as a first semester undergraduate student, I became obsessed, frankly, with philosophy generally and ethics in particular. And so I just started taking every course in philosophy that I could. I think I took something like 19 classes as an undergrad in philosophy, got a master's, got a PhD. I was a professor for 10 years. Always, I did lots of different stuff within philosophy, but my main focus was always ethics. And about 5 years ago, I left and I started this AI ethics consultancy for a variety of reasons, but one of which is I saw, or at least I had a prediction about the way that the world was going. And one thing that seemed to me that was quite clear is that AI was getting developed more and more. Lots of money was going into it. It has these pretty significant ethical implications for both businesses and citizens, countries, people generally. And so I thought, okay, companies are going to need to get their ethical houses in order. But they don't know a lot about ethics, but I do. And so off I went.
Yeah, well, and again, this is an area, one of the reasons that I am so incredibly pleased to be able to talk to you about this is what I'm seeing is the technology is pushing forward, right? You have private corporations, you have governments. I mean, everybody is developing and implementing variations and approaches to this technology. And it seems like ethics is, even though everyone knows that they need to work on this, it's something they're not working on, right? And so I want to touch now on your book, Ethical Machines. This was published by the Harvard University Press as a primer on key issues and ethical dilemmas, right? So who should be reading this as kind of a way to get started on this topic?
Yeah, so one thing is, it's actually not a Harvard University Press, it's Harvard Business Review, which speaks to the question because it's a business audience as opposed to an academic audience. Harvard University Press is an academic audience primarily. So I wrote the book primarily with business leaders in mind. It's written to be accessible to most anyone at all, because it's written, the business executive I have in mind knows nothing about AI and knows nothing about ethics and doesn't know anything about AI ethics. So it's really accessible to everyone, but the goal is really to teach both those senior executives at large organizations, but also junior data scientists and engineers, what AI ethical risks are all about, what their various sources are, and the kinds of things to be done to mitigate those risks.
Yeah, well, one of the truly exciting things about this is the way that you're applying this to business concerns, I guess. I do a lot of defense interviews, and so I've dug in a lot on the ethical dilemmas in that, that side of things. Now, I'll kind of come back to some of that later. But in terms of the business aspects of this, as I was going through the website, looking briefly at the book, I learned so much from that, and like one of the things to start out with that you've said is that AI's strength is that it learns from example, but it's also a weakness, right? Especially in terms of bias.
Yeah, that's exactly right. I mean, so first of all, I think that most AI around now, machine learning, can just be boiled down to software that learns by example. So you can talk about all different kinds of math and linear regression, and it's not linear regression, blah, blah, blah. You don't need any of that math stuff to understand the core of AI at the conceptual level. which is just software that learns by example. So you give it examples of, what your dog looks like, that it's just a picture of what your dog looks like. You give it a bunch of examples of what good resumes look like or good credit applications look like. It learns from those examples, and then it can make predictions about new ones, new pictures of your dog, new credit applications, et cetera. So that's what it's doing. And yes, in some cases, the examples that it's learning from may contain or reflect certain kinds of, let's say, historical practices of discrimination. And so what it will learn is, for instance, we don't hire women around here. And then it's going to reject female applicants, all else equal. So I think that's exactly right. I think it's the nature of the beast of AI, the nature of the beast of machine learning, that it's software that learns by examples. And because that's the kind of thing that it is, we get certain kinds of ethical risks that are quite likely, including especially issues of discrimination and bias.
Well, yeah, and actually the gender hiring was something I was thinking of too. So again, in terms of bias, we're talking about really implicit bias, which is a form of bias that occurs automatically and unintentionally that still affects judgments, decisions, and behaviors, right? And I know that there is intentional bias as well. I guess that might be another topic, but in terms of AI, oh yeah.
Yeah, I wouldn't say it's intentional bias. I think you're right about that.
Okay.
But I also I don't think that the contrast is implicit bias, even though that might be part of the story as well.
Okay.
So let's say this is a well-known case published by Reuters, I think in 2019. Amazon was creating an AI software to read all the resumes, and it trained it on the data, that's its own historical hiring data. So, hey, here's all the resumes that we got, tens or hundreds of thousands of resumes, millions of resumes that we've received over the past years. And here's the decision that the hiring manager made as to whether or not they should get an interview or not. So they set their AI on it. It learns by example what a good resume looks like. And what it learns is we don't hire women around here.
Yeah.
Now, the hiring person who was running that software, the data scientist running that software, the problem was not that they were biased or discriminate. They weren't biased against women, or they didn't want to discriminate against women. But it's also not because of the implicit biases of the data scientist or engineer. It's in that particular case, it's the data. The data reflects the fact that Amazon didn't hire many women over those past years. Then the question becomes, well, why does the data look that way? And then there's going to be multiple explanations, some of which involve discrimination and bias, some which don't. So one explanation you might give is the one that you gave, which is the hiring managers who were reviewing these applications were implicitly, and in some cases explicitly, biased against women. Yeah. So they judged them as not worthy of interview. And so that's one reason the data set looks that way. Another explanation for how the data might have gotten to look that way is that there's been certain kinds of discrimination against women at the sort of societal level that discourage them from going into STEM, into science and technology jobs. And so they don't go into, they don't apply for those jobs. And so there's a pipeline problem that Amazon inherited, didn't create. That's another explanation. Yet another explanation is maybe plausibly men lie on their resumes more than women do. And if they lie on their resumes more than women do, they're going to get interviews more than women do. So all three of those explanations can be true. They can all explain to varying degrees why the data looks the way that it does. There's more than likely a fourth and a fifth and a sixth explanation for why it looks that way. All we know is that the data looks the way that it does. And so the pattern that it picked up on is that we don't hire women around here, whatever the explanation is for that. And that's what it recreates and scales.
Yeah. And so again, this data, it creates this bias. That could apply to creditworthiness. That was one of the things that you talked about. Some of the other examples that I thought of were medical insurance, right? That would be a really important one because, that coverage, I mean, especially in terms of pre-existing conditions. Racial bias could be another one. There are lots and lots of these factors, and they pop up in business and medicine, hiring, as you'd mentioned, potentially college admissions, just any kind of selection process like that. And so this could be all over our society. And, if different companies are using similar AI systems, you could end up potentially with patterns that might haunt someone through their entire life based on things that are built in that no one's even aware of, just patterns it's picked up, right? So,
that's right.
Yeah. Well, so one of the things that I had read about myself was mortgage discrimination in the past in cities. And this was based on basically decisions based on districting that ended up disproportionately denying loans to minority applicants, even though this wasn't the overt intent, right? So they didn't set out and say, okay, we don't want to give loans to this group of people because we don't like them. They were just like, look, these are the higher risk areas for default. These are the lower risk areas. We're going to focus on these. We're going to break it up into a grid. And without even overtly realizing it, bias was built into that against minorities, right? So, so all of these seem like things that, the AI will have to be kind of measured against, right?
Yep, that's right. I mean, a lot of this is unintentional. Let's go back to the Amazon case for a second. Those engineers and data scientists working on that hiring software, they tried to debias it. So for instance, at first the software was noticing things like NCAA women's basketball. And so it would, red light as opposed to green light that resume. And the engineers said, no, don't pay attention to that. Ignore anything that says women's NCAA basketball or chess or whatever. Ignore the names of the colleges because there are some colleges that are women only. But what happened is that the software kept finding other variables that highly correlated with being a woman, such that they still got biased outputs. For instance, this one is particularly interesting, I think, because it's who would have thought. They discovered that men tend to use the word execute in their resumes more than women do. Like, I executed on this strategy. And since men, for whatever reason, use that word more than women do, so it picked out those resumes that use the word execute, which highly correlates with being a man. And so it still gets the same outputs. Your point about the mortgage lending is they might not have the applicant's name or their gender or their race, but they may very well have their zip code. And in the United States, zip code highly correlates with race. So if zip code plays a role in determining who gets a mortgage and who doesn't, then by proxy, as they say, race plays a role in determining who gets a mortgage.
Yeah. Well, and so this goes to the next subject that, again, this comes from your site and your book, Explainable AI, right? We need to be able to understand why AI makes decisions to ensure that bias isn't happening. The thing that immediately came to mind there was, court cases, law, right? I mean, so if one of these bias cases goes to court, which is likely to happen at some point, one of the first things that they're going to ask is, why did you make this decision? And one of the things that you talked about on the website is, even though AI has some element of black box technology to it, often, we need to be able to say, this is why it made this decision, because at some point you may have to explain that to a judge, right?
Yeah, let me put the point even a little bit more generally. So the reason we get the black box problem is, again, because of how machine learning works. What is it doing? It's learning by example. Let me say, it's like, so if you want a fancy word for example, you use the word data. And it's not learning by one or two examples or one or two bits of data. It's learning from, I believe the technical term is a shit ton of data, right? So it's a tremendous amount of data. So the patterns that it's looking for when you're feeding it all these resumes or mortgage applications or pictures of your dog Pepe or whatever it is, university applications, it's looking at thousands of variables and the mathematical relations among those variables. And the pattern, that mathematical pattern that picks out, is enormous. It's too enormous for we mere mortals to comprehend. Imagine, we understand the language of math, but imagine a formula that's 40 pages long. You just can't keep that in your head all at once. You get to page 2, you forgot what was on page 1.
So how could we possibly explain it? And let me apologize for this. Was when I was reading the site, I was like, how could you possibly unsnarl this mess? I guess if you've got formulas that long.
So in a way, you can't. What you can do is you can get explanations that are meant to approximate what's going on in the black box. So there are various technical tools that data scientists will use. Most well-known are, one is called LIME and others called CHAP, that try to figure out to what extent is this variable playing a role in the outcome. So maybe there's 12 variables, this person got denied. How much did this variable contribute to them getting denied or approved? These tools are necessarily simplifications of what's going on.
Yeah.
Right? They have to be simplifications, because the more you turn up, so it gets really good. AI gets really good at recognizing patterns. The more examples you give it, it's an example learner. So the more examples, all else equal, that you give it, the better it gets. So the more complex, the better it gets, which So that means turning up the complexity at the same time turns down the volume on explainability. If you turn the volume down to get more explainability, you're also going to turn the volume down on accuracy. So there's a trade-off between accuracy and explainability. That's one thing to contend with. And then the second thing to contend with is you've got these explanations using various technical tools to peer inside the black box. But these things are necessarily simplifications, because if they weren't simplifications, then we couldn't understand them either. And then the question becomes, to what extent are these simplifications distortions of what we're trying to explain, as opposed to genuine simplifications that give us a grip on what it is? Now, to your point about bias, et cetera, one thing that we're trying to do, one reason why explainability is important, is that one thing that we might be looking for is an explanation for the rules of the game. What are the rules that transform inputs to outputs? I give you some inputs, I give you some mortgage applications, you give me some outputs, approved, denied, approved, denied. What are the rules that govern that decision process? Now, it's crucial to know what those rules are, because if you don't know what the rules of the game are, then you cannot assess whether the rules of the game are fair or just or reasonable or any good. In some cases, you're just going to, you will be concerned about bias or discriminatory rules, but there's lots of ways for rules to be unfair, unjust, or unreasonable. Right? If the rules of the game place an undue burden on people, independently of what their race or ethnicity, for instance, happens to be, then it's not a fair rule. So we want explainability in some cases anyway, especially those high stakes cases where criminal justice contexts or healthcare, excuse me, because if we don't know what the rules of the game are, then we can't assess whether the rules of the game are fair, good, reasonable, and just.
Yeah. Well, so let me come to privacy next, okay? So you have written, I think this line is brilliant, the fuel of AI is people's privacy. And what that means is that organizations are incentivized to hoover up as much data as possible and use it to train their AIs, thus violating people's privacy. And that, again, that's your quote. I loved that because it, also it goes to this dial issue again, right? So not only does accuracy go up versus explainability, you would think that privacy, right, versus accuracy as well. I mean, the less information you give it, the worse decisions it can make. But and that seems like that leads to a whole host of issues also, right? Like if you choose to opt out, you may not be eligible for some services, or you may get denied, right? Because it can't make the correct decisions. So
yeah, that's exactly right. I mean, it's even more complicated than that, or the situation is even worse. Yes, the fuel of AI is data. It's often about people, data about people. Not in every case. You might just be predicting when the screws are going to arrive at the factory, and it doesn't have it. It's not directly people about data about people. And so organizations are incentivized to collect as much data as they can to train their AI, because all else equal, the more data you have, the more accurate your AI is going to be. So incentivized to get data about people. But it's not. So that's what's called training data. That's data that's used to train the examples that you give your AI to learn from. But then there's what you can call inferred data. That is to say, the outputs of your AI, the predictions that your AI makes. And in some cases, what you infer about someone can itself be a violation of their privacy. So let me give you a sort of a toy example that I like. Let's suppose, for the sake of argument, that you've got data about my geolocation throughout New York City, which is where I live. It's plausibly a violation of my privacy for you to have that data in the first place, but let's suppose, for the sake of argument, it's not a violation for you to have data about my whereabouts. Let's suppose you have another data set that is the addresses of, let's say, cancer treatment centers in New York City. And you give that to your AI, and it does its computation, and it infers, oh, Reid goes to this place every Wednesday at 3:30, and that's the address of a cancer treatment center, and so Reid has cancer.
Yeah.
None of this is true. So now if this is true, especially if this is true, it's arguably a violation of my privacy. You now have my personal health information that you've inferred from data sets that don't have anything to do explicitly with my health. And so it's not just the fuel that we use to train our AIs that threaten our privacy. It's the kind of inferences or predictions that organizations can make using AI that threaten our privacy.
Well, and I think in real world applications, this goes to something like, for instance, so many people use Google products, right? Google products are ubiquitous. They track pretty much everything. I think if people dug in, they would be amazed and probably terrified by how much data is in there. Everything that you have ever searched, probably every website, if you're using Google Chrome, every website that you've ever visited, I mean, all of these things, and they can
including
be
the incognito ones.
yeah, and they can be used, right? They can tell, okay, so they can tell, they could make very educated guesses about racial background. I mean, gender should be a no-brainer. Sexual preference, medical history, all of these things, right? So what you're talking about is, I think, what they call doxing, right? Would that be the word doxing, where they basically
I
create
always
kind
get
of a
confused about.
yeah, they create kind of a dossier or a profile for a person, and they say this is the avatar for
Yeah.
this person.
Yeah,
Now,
I think of doxing as de-anonymizing someone.
okay,
I
maybe
think that's right,
okay.
but I could be wrong.
So this whole idea of we can infer so much about people by their behaviors, and when you're tracking every behavior, even their subconscious ones, right? Now, one of the things, when you mentioned cancer, one of the things I'd wondered was, do you think that they might be able to infer things like that even if the person doesn't know it themselves?
Oh, absolutely. Yeah. Mm-hmm.
Yeah.
Yeah.
So,
I mean, because look, think about all the biometric data companies collect from you, right? You're wearing your Apple Watch, and Apple's, allegedly really good about this sort of thing, but there's lots of, Fitbits and things of that nature that are collecting biometric data about you, and they can be processing that data in various ways and making certain kinds of predictions about you and about your health that you're not privy to, because you don't know all that data. You don't have that data. You're not looking at that data. You don't know how to process it in such a way and make, strong, justified inferences based on that data. So absolutely, they can infer things about you that you don't know about you.
yeah. Well, and I mean, in today's world, this data is not used, I would say, very effectively. Um, Even if it is used effectively, it's not used gently. So I was doing story research not too long ago on biology and basically male evolution, right? And ever since then, I have been getting absolutely spammed with commercials for erectile dysfunction, right? I mean,
Yeah.
all over the place. And I'm like, okay, so here I am looking at biology sites, and I'm like, this is completely unrelated to me as a person.
Yeah.
But this, again, this correlation is in somebody's database, and now I'm just getting nailed, ad after ad after ad after ad from
Yeah.
a variety of companies, right? So
Yeah. I mean, I find that kind of thing very annoying. I'm not sure that it rises to the level of being unethical. I know that lots of people in the AI ethics space disagree with me on this. I'm actually not that worked up about targeted advertising. One, it goes so spectacularly wrong. Yesterday, I got the weirdest looking advertisement for a toenail cutter for senior citizens, and I thought, why am I getting this ad?
yeah,
They're so bad at it. And the other thing is that if they send me an ad that is relevant to me, and I buy a towel, worse things have happened. So I find it, frankly, hard. It's annoying, but I find it hard to get sort of, ethically outraged over targeted advertising in the way some people do, except in cases where it turns out to be, for instance, biased targeted advertising, and then that's a different problem.
yeah. Well, and again, and this comes to, I guess, de-anonymizing people, right? So if they're showing people ads related to something that the person is trying to keep quiet, right? Like, so, erectile dysfunction would be one of those, or someone's sexual preference or things like that.
Sure, yeah.
Yeah,
There's sort of an infamous example where I forgot the details, and I remember the details are actually more fine-grained than what I initially thought they were. But it was something like Target was sending advertisements to a woman for something to do with like having a baby, and she didn't know she was pregnant yet. And I think her family found out, or something along those lines. But if not that exact story, something like that thing is very, very easy to happen.
Yeah. But then, on the other side of things, even if it's only annoying, I think what it also shows is that the way that data is actually used, it's not gentle. It's more like they crash a plane through your roof to tell you something, right? I mean, it can't be any possibly less subtle. So,
For
in
now.
for now, yeah. So with AI, that's also a little bit scary, because if the AI makes these determinations, if that bias leaks in, if it's using that private data, it's very, very interesting, all these possible implications. So
yeah. And we haven't even talked about use cases for AI that are privacy undermining. So various kinds of surveillance technologies that are AI enabled, most famously facial recognition software. So that's not about the inferred data or the predictions that the model is making. It's something bigger than that. It's a use case for facial recognition. The use case that is driving the privacy violations. It's not because a model made a prediction about you. It's because I'm using AI to power my facial recognition software to pick you out of a crowd so I can, harass you, for instance.
Well, so I do want to touch on the military briefly, because this is something that I've been following. Drones, I would say that automation in the military has been moving so incredibly rapidly. It's a dizzying pace, right? I mean, the Predator drone in the 90s, basically it was just a big RC airplane with a camera, and then it started firing missiles. And now we've got in the Ukraine war, they're using autonomous drones, right? And so one of the things that they've said all along was there will always be humans in the loop. These things aren't going to make their own decisions. And as I recall, the British government is reconsidering that. And I believe the US government is starting to look at that as well. And part of it is just because of the speed, pace, and the intensity of warfare.
Warfare, yeah.
Yeah, the humans just can't keep up. And even if we decide for the time being, we say, okay, well, we're never going to take people out of the loop. If the other side does that, then we may have to. So what seem like, in some cases, mundane, I guess, ethical decisions today are going to become life and death tomorrow, right?
Yeah, that's exactly right. The human loop thing it would be nice, arguably, but to your point, especially in warfare situations, things are happening so fast that there's no way that a human could actually keep up with the quantity of outputs of all these algorithms, of all these models. There's just no way. And again, to your point, I'm just echoing what you said, not saying anything really new. If the enemy is not, if they're moving way faster than you, then you've only got really one plausible option. So human in the loop is nice, but there are some situations in which it's clearly not plausible, which is just simply terrifying, because automated decisions are not very good at paying attention to shifting context. And shifting context means everything in terms of what the impacts of what you're going to do are. So if you can't, in an automated fashion, pay attention to various significant features of the context of the situation, then you're going to wind up with, to put it sort of technically, a lot of false positives. To put it non-technically, you're going to wind up with, in a warfare situation, lots of dead people who shouldn't be dead.
Yeah. On that note, Reid, let me thank you.
Happy note.
Yeah, let me thank you so much for your time. We're pushing a little bit over our schedule. Let me apologize for that.
No worries.
Thank you again. I would love to talk with you more about this in the future. And for now, let us adjourn, and I will point people back to your book, Ethical Machines, and I'm going to put tons of links in the show notes to all of your materials so they can learn more.
Thanks so much, Tim. Been a pleasure.
Thanks again.
Bye-bye.